have a Leetcode question, and today questions is we have 2306 naming a company, and let's read this question. So question is saying that you are given an array of idea, right? You are given an array of string ideas that represent a list of name to be used in the process of naming a company. So the process of company is you have to uh, choose like how name choose a distinct name. Okay, what you have to do to choose a choose two distinct name from ideas, right? We have to choose from the ideas array and call them idea A and idea B. Now swap the first letter of idea A and idea B with each other, right? And then if both of the names are not found in the original idea, if both of the name are not found in the original idea, then the name idea A, idea B, the concatenation of idea A and idea B separated by a space is a valid name, and otherwise it is not valid. Now what we have to do, we have to return the number of distinct valid name for a company. Okay, for the company. So 3 points especially we have given. We have to choose the distinct names from the idea, two distinct name, and means two unique names, and then we say idea A, idea B. Then we have to swap the first two letters, right, of the chosen names. And third, what we have to do, we will check if both names are not found after the swap, right? So in the original idea, it means the name idea 1 and idea B is a valid name, and so we can say it is not a valid name. Okay, and we have to return if it is not valid, then we have to find the total number of distinct valid names and we have to return for the date for the company. Okay, as an output. Now what we have given here is we have given example one in which we have given ideas. So the first idea we have given is coffee, second we have given donut, time, and toffee. Okay, these names we have given, and output is 6. So let's understand the first two things we have given. What if we'll choose for idea A, if I'll choose coffee. Okay, what we have coffee, and similarly if I'll take idea 2, and in idea 2 I will take coffee, and then what we have donut, right? Donuts we have given, right? Donuts. So after the swap, right, what will happen? We have to swap what? The first letter here is C, and here what we have is D, right? So if we will swap this one, right, it is showing it is saying that the first letter of this idea A and idea B we have to swap. So D will come here and C will go there. Okay, so first I'll write for here, I will write after swap. We have did the swap, the first letter swap. Now it is DOFFEE, right? Doffy. And in idea 2, idea you can say idea, sorry, this is B. Okay, idea B, A and B. So in this it will come what? CONUTS, conuts. Okay, Doff, it is coming Doffy and conuts. So if I'll find this Doffy and conut in which table? In this one, right? So if this is not available, so there is not available. Okay, it means these two are unique, that we after the swap we have found. It means these two are uh, unique, and we'll say that this is a valid name, right? And similarly we'll take time, toffee, like that we will take. Similarly if we'll second time will come for the donut, time, right? So if we'll change this one, so donut and time, so it will come donut, right? And time will become dime. So if you make all the combination, right? So first combination, as you can see here, it is given coffee donut, donut coffee, donut time, donut toffee, time donut, and toffee donuts. Total is 6 combination we have, and they are unique. We are getting the unique as a valid name, right? But if you'll take time and toffee, right? So after the first letter changing, the name value is same and it's not a valid, right? And so we can say that we will not consider this one, but we will consider other 3 combinations, and that is total 6 out we will get, right? So I think you have understood. Similarly, next we have lag and back, right? So if you'll take here lag and back, so I'll take lag we have, and here is back. Okay, so first change this this one, so it will become back, and this become lag, right? So there is no this is not unique, right? And so that there is no element we have, and so we will return 0 as a output, because we don't have a valid you can say uh, names for these two, right? This combination idea, because we have taken a idea A and idea B, and no combination is available here, right? But constant we have given now, as you can see here, is idea length is greater than equal to 2, means minimum 2 combination will be there, and it is 5 into 10 to the power 4. That's you don't need to consider this one. And the second, we have idea of I consists of lower English letters only, and all string is idea are unique. The given idea and strings are unique will be there. Okay, so let's go to the browser section of this uh, code, and we'll do that. Okay, so what approach we will take this one? So first approach we will take this one is we can compare word by word, and we'll try to implement this one. Okay, so actually in this problem what we will do, we have given array of string, right, ideas, and as you already seen, right, we have given like some of the things we have given. Let's say suppose we have given coffee, we have given, right? Then we have given donuts, I think. Then we have given time and coffee, right? Toffee, sorry, toffee, not coffee. Toffee we have given, right? These things. So we have given, you can see that these names are what we have given. These names are different, right? So if I'll and we are supposing that these names are in array like this. These are in array we have given, correct? And so for each name, right, each name is unique. And if I'll consider these two, and we'll say I'll take these two and we'll swap, right? So after the swap, what is coming? It is coming C will come Doffy, right? We have already seen this one. And another is coming uh, Conut, Conut, right? Conuts. This is donuts. It will become conuts, right? So this will look like this one, correct? So as you can see that we can pick two different names, right? We can pick two different names. So next time the possibility will be become what? This and can be this one, right? So I'll take now second time we will take what? Coffee and time. Got it? And then we will do the swap similarly, and we'll get some value, right? Similarly, we'll take the combination of what? This one only. I'll take this one, and then toffee this one. But this will not work because the name are same. It will not come valid, right? Toffee and coffee will remain same. Next time what we will do? Then we will take the combination of this and this, and then this and then this. Like this we will make total combinations, right? So what we can do, we can pick two different names from the ideas, right? Always focus on this one, the idea array, and we will take two different names from here, and we'll swap the first letter, and then the thing that will come, right, and that should be unique. If we'll say we have selected this one, then it will come like this one. Okay, So mainly here two things is there, right? So if we'll select, right, the combinations, right, so we will get some combinations, and after that if both are coming same, right, if after the exchanging it becomes same, then we will not take that one. It should be a different letter, correct? We have to take different letters. Okay, so we'll try to use this name solution for each pairs. Okay, so now what we will do, so in this way if we'll compare, one thing we have to understand is that so if we'll do like this, right, we are swapping each time new value, right? So what we have, we will have, so the what given size of the input area, right, area we have, if this is the size is n, let's suppose the size we have given is coffee donor time, this array we have given n. So what we have to do, for each pair we have to consider what, on square, on square pair of words, right? See, we have given 4 here, right? So total combination what we have to check, 8, but one of them will not work, right? Like coffee and toffee will not work. So total what is coming, 6 pairs it is coming, right? So total n square pair we have to check, right? So this approach is likely exceed the time limit, right? That imply that we should look for the better approach, right? So what we should do, we will notice that two different words have the same letter initially, right? Then swapping them will not create a new letter, as I told you, right? Like coffee we have and toffee we have, right? So both words have the same initial name, toffee and time, let's suppose. So if we will take toffee and time, right, so this will not make any new sentence. Similarly, if we'll take coffee and time, this will not make a sentence, right? Because there is what happening, we can group the suffix of all the words in the idea by their initial take, right? What I'm saying, let me repeat again. I'm saying if we have two words have the same initial letter, right? Like we have what, we have time we have given, and one will take time, another will take a we can say toffee. Yeah, toffee we also have, right? So we'll take toffee. Let's suppose time and toffee we have. This is idea A and this is idea B. So after the swap, what will happen? It will come, if after changing, the same will come. Time will come and toffee will come. So these names are already in the idea table. Similarly, if we'll take what, coffee. Let's suppose coffee we have and time we have. So if we will do the swap, right, this is A and this is B, idea A and idea B. Okay, so after the swap, what will come, coffee will become toffee, but this name is already in what, already present, and time will become something else, right? uh, Sime, something Sime, but this is there, right? So this name is already present, right, but this is not present. So what will happen here, so what we have to do, we can group the suffix of all the words, right? All the suffix word we will group in case of by their initial names. Let's suppose let's suppose there is an example. We will take an example, we can take apple. Let's suppose we'll take apple. Okay, so what we'll take, we'll store, rather than apple we will take uh, PPLE. A will not store, we will store this one and set marked, like we will set this is marked. We have already gone through that with a letter, with a letter A. We will map like A. So we have already done this one we have already done. We have two different words we have, right? Let's suppose we have what, we have coffee. Okay, and another what we have, time. This is A, this is idea A, and this is idea B, correct? We have two words and that have different initial letters are different, right? This is idea A and idea B, right? So what will come now after the swap, what will come now? So let's suppose it will come what, it will become toffee, and this time will become same. Got it? We will got this. Obviously we will got this, right? After this, right? So hence what we can do, we can make the group with the suffix of all words in idea, right, by their initials, right, the initial letters we have, right. And we'll take let's suppose we'll take an example of apple. We have an example of apple, right. So what we will do, from the apple we'll take what, p p l e, and initial letter will not take here, right. And we'll say for this we will store this what, ple pple in a set, right. We will store in there with a letter a, okay. And we'll say like I want to say like this is a and this is pple, like this. We will take this like, and we will mark this uh, as a letter, right, this one, that is marked sorry. We'll mark this that since swapping any two words from the same group always creates two invalid names, right, after swapping. So we only need to try swapping words from different groups. In, it means like let's suppose what I'm trying to say here. We have some letters we have. Let's suppose we have given what, we have a group A, and we'll take an example, Y L P H A A A P L E. These are the groups we have for A. For B, we'll take some group. For group B, we'll take some prefix, like you can say suffix. You can say like we have at, E E F, and Y E. There can be anything. Next, we will take this group and we'll say this group will contain what, A R. Then we have at. Like this, we will get a lot of other values, other suffix values. Similarly, if we'll talk about Z, we have EUS, something can be ELU, right. Like this we will get a you can say groups, and all the groups will contain its values. Okay, understood. So these suffixes are having a group. Like for A, for apple, we have taken the apple, right. So this apple have the suffix what, pple, right. So what we'll do, we'll make this group like this one, and we'll say this pple, sorry, this is a pple, right, pple, and this is in this group. Okay, now I think you understood, right. So next time what will happen, for two groups with the initial letter, what we have, let's suppose we have A and B. Okay, so for two groups with the initial letter, we have A and B, right. So if a suffix is contained by two groups, right, if a suffix is contained by two groups, then what we will do after the swapping, after like some let's say some letter we have here, some suffix we have, some suffix here. So what I'm trying to say, for two groups with the initials is A and B, but the suffix is same, right, both have the suffix same. If a suffix is contained by both group, A will contain and B will also contain, right. So what happened after the swapping, it will come A plus something comes suffix, right. Similarly with the other words in B, it is what, it will become what, invalid, right. Similarly as a new name it will come, new name will become what, B plus suffix after the swap, right. So this name will be already present in the group B, right, because after the changing this will go here and this will go here, right. Means what will happen, as we have already seen these things, right. So what will happen, similarly the swapping of B plus suffix with any other group in A is invalid, as well as a plus suffix is already present in group A, means after the swapping both are come invalid. That we have already think. So this will become a rule for us. So here why I am saying that here A and B are variables representing letters, not literals, right? Not literals. Suppose. Now think, since two words A and B, what we have? Since two words we have this A plus suffix and B plus suffix, right? So what we will do? What we will do here? Let's suppose we'll consider A plus suffix A. I'll take A suffix underscore A. Okay, and another will take B plus suffix under B, and these two can be swapped, right? See, this letter is, this suffix and this suffix are different, right? And then it can be swapped to generate two new names, correct? If we will swap these two, if this is group A, this is idea A and this is idea B, right? Idea and B idea. So after the swap, what will become? It will become A plus suffix B, and here what will come here? B plus we, after the changing, right? It will come, yeah, it will become like that only. B plus suffix suppose A, right? So these two names will come. We can take here or here also, no problem. So these two names will be generated, and these two names are new names, right? Only if their suffixes are distinct. So here what we have to do? This suffix is unique suffix. So this is also unique. So if the suffix is duplicate, right? Here if suffix are duplicate, means common, both have common, right? This is there and this is also there. It means both are not distinct. Suffix are not distinct. In that case it will come invalid, right? And if suffix are unique, and that's why we will get what we can say unique, because here we are getting what? Suffix here and here are unique, and these suffix are unique, so we are getting what? Valid one. We'll get valid new names. But if the suffix both are same, right, that is, you can say unique, right? So it is coming duplicate new names are coming, right? After the it is changing, it will become what? B plus suffix only, A plus suffix only, and this is invalid, correct? I think understood. Next time let me do a little bit here. So after the swapping, two names are coming, you can say what? New names are coming only if their suffix are distinct. That is, neither suffix A, let's suppose we have suffix A is in a group B, or not suffix B in suffix B in A. Neither this suffix A is not in what? B. This is not in the group B, because this was in A, right? And in suffix B, that is in group B, is not in what? You can say not in A. It is not available. It was not available, right? And so this is happening, right? Now what we'll consider, we had, right? We had taken two group. We have already taken, right? Let me change the color. Okay. Let's suppose we have A. What we have? A we have, and another we have B. A we have and B we have. So if we will take P P L E, another will take what? L P H A, and in both we have one common Y E. let's suppose. And in B group we have some suffix AT, EEF, let's suppose. So if we will represent group A, it will represent like this, and similarly if we represent B, it will represent like this. In both, what is common? This element is common. So here what we will think, that PPLE is not in group what? B. That is not in group B. A at AT, similarly AT is not in what? A. Similarly we'll say that, and we can swap these two. If we'll do this swapping, right, so we will get what? If we will swap this one, will come what? This is A and this is B. So after the swap, it will become what? We can swap these two, right? So it will become A double P L E. A will come from here and PLE will come from here. Okay, so it will become. Now similarly another word will come. What? Uh, we have B already, we have, and it will come AT. So it will become bat and become apple, right? Similarly common, why we have both places, right? So YE is in group what? A and B, both group we have. So after the swap, it will become what? YE, and again it become a BYE, let's suppose. I or by, right, with any words. And if we will swap these two words either here or here, it will become the same word anywhere. So after the swapping, it is no value of swapping this one, but here we can swap, and this we will get a unique values, apple and bat. I think now you have understood, right? So what we will do, we need to try every pair of initial A and B groups, right? And then we will find the number of distinct suffix in both group. We can swap every unique suffix in groups. You can say distinct suffix in a group A with every distinct suffix in group B to make two valid company names, right? So what we will do, we can get the number of distinct suffix by the first getting the number of mutual suffix, we can say. Okay, so what we will do, like that we have seen, right, this one, right? So mutual suffix in both group we will find, and the number of, we have what, number of distinct, or you can say unique suffix, we will try, we will find the number of unique suffix equal to the size of the group will do, and minus number of mutuals. As you can see, right, total what we have, this we have, this we have, this we have, this we have, that we will do. So give me 1 minute. What we will do here, I can take the eraser, let me remove from here. Okay, let me remove from here. Okay, so this was our A and this was our B, correct? Now the combination, I told you how we will make that mutuals. Let we have A, we have, and another is we have B, right? There it is what we have given, PLE, right? And here is AT. Similarly what we have here, LPHA, another prefix is LPHA, another is EEF, correct? So these combination we have here, right, this is a group, this is the, you can say, initials we have A and initial B we have, right? So what we will do, after the swap, these two will work, right? This will work. Similarly this will also work, right? This will also work. But if we'll make this one, this will also work, right? And similarly we'll take these two, it will also work. So these are total combinations we have, right? And we will have our what, mutuals, right? Distinct mutuals we have, we have our total number of, you can say, suffix, right? Distinct suffix we have, and equals the size of one group. We'll do that. So now one thing you will understand here is that what we have to do, we will group words in ideas by the initials, right? Let's say these initials we have A and B. Will take a array of set of 26 letters we'll do, right? And we'll try to find the answer. What we'll do, we will iterate every pair of groups, right? For we'll say A and B, and we will get the number of suffix, number of mutuals, right? That we have find from here, that as we have find here, right? We'll try to find the what you can say, number of mutuals that appears in both group A and B, and then we will swap every distinct suffix in group A and group B, right? Every distinct suffix in group A with every suffix in group B, right? And then we will increment each time answer. How we'll do that? You can see here, 2 into the length of group A, group we'll say group A, and minus we'll do number of mutuals, right? Number of mutuals, what will come, the mutuals, will do this formula, and will multiply similarly the length of group B, and we'll do minus mutuals, right? Like this we will do, and finally that we will return as a answer. And why we are doing this one? So you can see uh, here, if the take the length, right? Total how many it is coming, the group total group length is what, A and B, two we have, right? And how many mutuals is coming, there is only one mutual is there, right? So 2 minus 1 is 1, right? So what we will do here, 2 into what we have, 2 minus 1 is 1, so 2 is 2. Similarly we will check from this one, how many mutuals we have, 2 we have what, 1 minus 1 mutuals, right? And then we will find total mutuals. So how many is coming, then we will do multiply, right? So similarly we'll get the, that is whatever the value will come, that is our output. Okay, next time we'll update our output and we'll return the output. So let's go to the browser section and we'll try to implement this one, implementing from here. Okay, so we will group the idea by their initials, right? So we will find all the initials name, like the first letter of the you can say idea, right? So how we'll group that, we can store all the 26 letters, right? And we'll say that we will take as a unique, right? So what we will do, we'll take has set of what, string, right? Then we can take has sets of string will take, and this will take as array, right? We'll store a group, right? So we'll say this is a group of has sets in array, and we'll take this is our initial group, we'll say our initial group, and this initial group will store what, is nothing but our hash set, and this hash set have 26 letters, right? 26 letters name we will have, and that is our hash sets, right? Now what we will do, next time we'll initialize this all the loop, right? So we should initialize with, we'll take int I is our 26 letter will start, I2 what will go maximum 26 letters, right? And then we will do I plus plus. Next time what we should do, we will update our we have to initialize our initial group, and that we have to do like for each index we have our hash sets, we'll say has set, and this is nothing but a string type, so we'll put like this only, so this will work. Now what we have, for all the idea we'll take one by one two pairs, right? So let's suppose we have idea string, we have this is nothing but our idea, okay? And this idea will we can take from what, ideas, correct? Now what we will do, initials group we have, right? initials group we have, and on the initials group we will take idea, and this idea is nothing but its first character, and that is our initials, right? So we'll take the initials from index 0, right? So idea at char 0 will take the initials from idea A. Now we have to mark, so we will mark like this. You already knows, right? So we will mark. Now what will happen after marking this one, we will add all its suffix. So we will add, it should work. So we'll add what, the suffix of this idea. So we will have our idea. On this we'll call substring to get the suffix, and we'll start from 1. What will after the 1, 0 we have already taken as a group, and now on the 0 we are making suffix groups. So like we will do, so it will come like what, a have what, a, like this it will come, a have, it will mark like the first group, it come a ppla, sorry, ple. Next time if a is combination of anything like app we have, so it will come a p e app we have, right? So a will remove and will come like this, will store, right? That we have done. Now what we will do, we will calculate the number of total valid names that will come from the every pair of the group. We'll take the group, and from the group we'll find the every pairs, right? So for that, what we have to do, we will go to all its length, right? All the groups you can say that we have initialized. So total how many groups we have created? 26 group we have created. So for that we will start with the group. Let's suppose for group we have int, I'll take a. For group A, I'll start with 0, and I'll go to a should be less than 25, less than equal to 25 will say total group will have, right? And then I plus plus 26 we can go, a 26 group will be there, we can go, but we'll go to, because we have to do you can say calculations, right? Because we have to take the pair, the next pair will, because adjacent pair we have to take, and that's where we have to take less than 1. So this is our a. Okay, for all the group a, we can say group a, you can take also group a also, group a, group b, we will make all the combination. Well, we'll take like this only. For all the group a, we will have our group b, right? So group b will start from b, and that is nothing but what, a plus 1, that is adjacent of a. Adjacent of a is group b, correct? A and b. So this b will go to what, we can say b will go to what, 26, and then we will go j plus plus. Now what we will do, get the number of mutual suffix. We will try to find the number of mutual suffix. So find the number of mutual suffix, right? We'll try to find the mutual suffix. How we'll do that? We have to go to we will take you can say group, right? From the group we will take the suffix. So let's suppose we'll take a string, I will take idea, we'll take a. This is idea a, and from here what we will do, we'll take the from the initials, right? We have our initials, right? Initials, why it is not coming? We have initial group, right? So on the initial group we will have a. So from a we will get a group, so we will get this group. So that is our group a. On this one, like for all this one, we will have our idea, right? So I will try to find if we have this idea is we can say this idea contain this initial group will have our idea B, correct? So if B contains there is a method contains, I will try to find the idea is there. If idea A is there, means we have uh, you can say mutuals, right? We have the mutuals. So what we will do, we will have our mutuals, right? And we'll update our mutuals. So we'll initialize the mutuals on here. We can take, yeah, we can take here. Okay, from here we'll take int mutuals equal to, okay, 6 0. Now this is done. We will get our mutuals, all the mutual suffix, okay, total number of mutual suffix we will get our, right, mutual, and as mutual, take mutual suffix, sorry, we will have our mutual suffix. We will update our mutual suffix. Once it is done, then what we will have to do, uh, before closing this for loop, right, we will update our valid names. So we have our valid names that are, you can say, distinct, that have the distinct suffix in both group, right? So what we will do, we'll find we'll do the swap with both group A and B, and we'll swap with B and A both group, right? And find the we'll create the two valid names, and that is we will multiply the answer by 2, right? Because we are getting from two names, right, each time. So how we'll get the two names? So we will have our, we'll take one uh, total names, total names, you can say the combination of total names, we can say distinct name, total distinct name will get, and that is will take a output, and that is nothing but our 0. Okay, so this output we will update here. So each time we'll get our output, correct, here. So this output we will multiply with the 2, because we are getting at a time two names, right? And we will update each time after getting the from the two names, two group, after two group we will swap idea A and idea B, and we'll get our names. So from the initials we have the initials group, right? So our the initials group at A, we will have some size, the length, we'll find the size, that is the length, we can say, and we'll do mutual suffix. Oh, it is not coming. Okay, we have taken these mutuals here, right? So what we will do after this, we have to go, we'll update this one, we will get A and B, yeah, here only. Okay, we will go mutuals, we will find our mutuals suffix, we will have, right, all the mutual suffix we have, number of mutual suffix, you can say. Into we will multiply with the same things, group B, for the group B, correct, we can take from here to here, here to here. Okay, so we'll take this mutual, this will become B for group B, right, and will remain, everything remains same. And finally, once this is done, right, then we will return our method output. So let me check once more. Yeah, what we have taken, we have taken output, then we have taken initials group. After the initials group, what we will do, we'll update our initials, initialize our initials group. Then what we will do, we'll make the groups, right? After making the groups, we'll go to two groups and we'll try to find our mutual number of mutuals, right? And then we will update our answer with initials group, will update, right? From the initial group we'll take the two unique names at a time, so that we will do 2 into length minus mutuals, length minus mutuals. Yeah, let me So I think we have taken J here, so we'll take B. Let me submit this one. Yeah, this will work. Let me check. Wrong answer is coming. Why the name wrong answer is coming? Okay, so what we will do here, see, first we have taken idea, then we have taken names, output, right? Then we have taken what, strings, this one, it is also good. Now we'll start from I equal to these two, I equal to 0 to 26, and we'll update our hash sets at this time, right? And then what we will have, our ideas we have in the string. Then for we will make all the groups here, idea dot substring from the one. Then what we will do, we will have our we can say loop, and we'll start from what, a to 25, and then b plus 1 to 26 will go by the for the b. Then we will have our mutual suffix, right? And this mutual suffix will get our initials, right? Initials will update our we can say mutuals. We'll have our mutuals. Then what we will do, we'll do output equal to plus equal to 2 into initials group of I, right? Group of I, the length minus number of mutuals, and then this, and finally we will return our output. Yeah, this is fine. So what we will do now, yeah, this will work. So if you'll find any solution, please ping me here in the comment box. Okay, thank you so much, guys. So hello guys, only you have to update the data type as a long and it will work, right? So this was the mistake that we should check take the long as a output, because return type is long, so we have to take the long as output, and that's all. So please fix this and submit this one. This will work. Thank you so much, guys. Thank you so much.